Hello and welcome to the Math Fundamentals Workshop. Today we will be going over fractions, decimals, and percents, algebra basics, one variable linear equations and inequalities, exponents, factoring, and polynomials. With fractions, adding and subtracting is where you have to find a common denominator. If you have a common denominator, all you have to do is just combine the tops of both fractions. We have 1/5 plus 3/5. Well, you just combine the tops, so that's 1 plus 3, that's 4. Now you have 4/5. Now, if you have different denominators, your goal is a little different. You have to get the same denominator, then add them. So the way we get the same denominator is we just take the denominator of our second fraction, multiply it on the top and the bottom of our first fraction, and take the denominator of our first fraction and multiply it on the top and the bottom of the second fraction. So 7 times 1 is 7, and 7 times 2 is 14. 2 times 3 is 6, and 2 times 7 is 14. That's how we get 7 plus 6 over 14, which is 13 over 14. Now to multiply and divide fractions, make sure you cancel out any common factors between the top and the bottom of the opposite fractions. Meaning we have 15 over 4 times 3/5. Well, we do know that 15 divided by 5 is 3. So we can cancel out this 5 because it's less than 15 and change the 15 into 3 because it's greater than 5. That's how we have 3 and 1 here. Now we have 3/4 times 3 over 1. Now you just multiply straight across. 3 times 3 is 9. 4 times 1 is just 4. That's how you end up with 9/4. Now, if it's division, you just flip the second fraction, and it's now multiplication. Now, if you want to convert a decimal to a percent, just move the decimal 2 places to the right, or multiply by 100. See here, we have 0.15. To get that into a percent, you just take this decimal point right here and move it 2 places to the right. 1, 2. Now we have 15. Or you can multiply by 100. Now we have 0.08. Move it 2 places to the right. Now we have 8%. Now to convert a percent to a decimal, it's the opposite. You just take your decimal place here and move it 2 places to the left. 1, 2. Now we have 1.3. Or you can just divide by 100. Now to do math with percents, first convert them to a decimal or a fraction. So let's say you have a percentage. If you divide it by 100, you can keep it as a fraction. Or if you multiply, or if you divide your percent by 100, you can just get the decimal. An interesting trick is that you can swap the percent to make things easier. So 8% of 25 is the same thing as 25% of 8. And 12% of 50 is the same as 50% of 12. Algebra basics. First, we have the order of operations, PEMDAS, as many of you well know. You start with your parentheses, then move on to your exponents. After you've evaluated your exponents, you multiply and or divide from left to right. And after that, you just add or subtract. So let's apply that here. So here, actually, we have different laws here. So you've got the commutative law of addition, which is just saying that A plus B is the same as B plus A. Then you have the commutative law of multiplication. A times B is the same as B times A. Then you also have the associative law of addition. A plus parentheses B plus C is the same thing as parentheses A plus B, and then plus C. And you also have A plus, and then parentheses B plus C. It's the same as parentheses A plus B plus C. Meaning, it doesn't matter how you evaluate, or it doesn't matter if you evaluate from right to left or from left to right when you're adding. The associative law of multiplication just says that it also doesn't matter whether or not you evaluate from left to right or from right to left. If there is only a multiplication happening. Now you also have the distributive law. So if we have A times B plus C, that's the same as A times B plus A times C. Now, I think it's just repeated right here. Okay. Now you have the cancellation laws of addition. A plus C equals B plus C is the same thing as A equals B, meaning that C doesn't really need to be there because you can subtract it on both sides and you get rid of the C. So if something just if the same number is added on both sides of the equation, it doesn't really need to be there. That's what that means. Cancellation law of multiplication. A times C equals B times C. Again, we have the same operation being applied on both sides, and so that number just doesn't need to be there. So we can cancel out the C. And that's as long as C is not 0. So if you know C is not going to be 0, then you can actually apply that. But if C is going to be 0, then the whole equation just falls apart. Where you have 0 equals 0, and that's just true anyways. Now, if you have equations of one variable and you have to solve for the variable, meaning variable meaning the letter in the equation, just apply PEMDAS backwards, as this meme implies. So say we start out with negative 7x minus 9 equals 2x plus 3. You can apply PEMDAS backwards. So let's go ahead and do that. So PEMDAS is parentheses, exponent, multiplication, division, addition, subtraction. So applying it backwards means we're going to apply subtraction, addition, then division, multiplication, then exponents and parentheses. So let's work out that. So let's apply addition and subtraction. So let's go ahead and get rid of the 9 by adding 9 to both sides of the equation. Negative 9 plus 9 goes away, and 3 plus 9 is 12. And now it doesn't matter whether or not we chose to get rid of the 9 or get rid of the 3. Here we just decided to get rid of the 9, so we added 9 on both sides. Now we have negative 7x is equal to 2x plus 12. Now, in a move to get all of the variables on one side, we've decided to subtract 2x on both sides here. So that's what this whole shebang in yellow is all about. So we're taking negative 7 minus 2x, then 2x plus 12 minus 2x. Now 2x minus 2x is gone. Now we have negative 9x equals 12. And we just divided by negative 9 on both sides. And that turns into 1. Now we have 12 divided by negative 9. And if you were to simplify the fraction, this is what you would get. Now, if you're ever, just some weird things that you might run to, if you're ever asking, where did the variable go? If it simplifies to a statement without a variable, it means one of 3 things. You messed up somewhere, there is no solution, or any old number will work. So if you run into 5 equals 5, it means anything goes. If you get 4 equals 7, there's no solution. But generally, this means you messed up. And things can just, it's best to backtrack or either restart the problem. Suppose you have inequalities and you're trying to isolate your variable. Things, just treat it like an equal sign. Nothing new here. The only exception is if you multiply or divide both sides by a negative number, then you just flip the sign. As the PowerPoint says, a greater than sign becomes a less than sign, and a greater than or equal to sign becomes a less than or equal to sign. So yes, don't just treat it like an equal sign. Don't really, the behavior doesn't change so drastically that you can't solve the problem anymore. Now, exponents and roots. So exponents mean that you have that many of the base multiplied together. So we have 3 to the power of 4. That just means that's 3 times 3 times 3 times 3, which is 81. And x squared is just x times x. This is very important to know. Now, roots mean the number that is multiplied together is the root number of times to get to that number. So let's imagine we have the square root of 36. Well, there's a 2 above this little radical sign. That means it's going to take 2 times 6 times 6, or 6 to the power of 2, to get 36. That's why we end up with just 6 at the end. Now, this 3 up here just means it's going to take 3 multiplications of 2 to get 8, which is why we have 2 here. Now, let's go over some exponent rules and laws for the product rule. A to the power of m times a to the power of n is just the same thing as a to the power of m plus n. As long as your base is the same, you can actually do that. Now, a to the power of m divided by a to the power of n is just the opposite, where a to the power of m minus n. As long as you have the same base, multiplication is just addition of powers, division is subtraction of powers. Now, if we have parentheses involved in this, that really means that's a to the power of m times n. So parentheses mean multiplication, multiplication means addition, division means subtraction. Now, here, this just shows us that the exponent can be treated like distribution. You can distribute the power of m throughout the entire side here. We have a times b, and then the whole thing to the power of m. It's the same as just a to the power of m times b to the power of m. That's where distribution comes in. Now we have power of a quotient rule. So suppose you have a to the power of m divided by b to the power of m. You can simplify that by putting parentheses around the whole fraction and just putting that exponent up there. Now this only works as long as you have the same exponent. So this does not work if you have a to the power of m divided by b to the power of n. Yes, we also have the 0 exponent rule. Anything to the power of 0 is just 1. And the negative exponent rule. Anything with a negative exponent is just itself in the denominator. So a to the power of negative m is really just 1 over a to the power of m. Now you have the fractional exponent rule, which is where a to the power of m over n is the same as a to the power of m under the nth root, where the bottom part of the fraction is the root and the upper part of the fraction is just the exponent. Pretty interesting stuff. Factoring and polynomials. So with factoring polynomials, make sure you factor by grouping. So first things first is we have to get the polynomial in order from most x's to least x's. Basically saying we have to get this in order from greatest power to least power. So we have x to the power of 2, and we have x to the power of 1, and then we have no x. That's the right order, so we are all good there. Now, the next step is to take your first number, multiply it by the last number. We get 30. Now, let's two factors of that new number to find to that add or subtract to the middle number, which is 11. So we're going to find two numbers that add or subtract. 5 times 6 is 30. And generally, the best process to do that is just to put in a bunch of numbers on your calculator until you find something that adds to 11 and multiplies to 30. So lo and behold, 5 plus 6 and 5 times 6, 5 times 6 is 30 and 5 plus 6 is 11, which is exactly what we need. So now you just separate it. We have negative 3x squared plus 5x plus 6x minus 10. Now break up the middle number into the two factors. So this is how we do that. And you find the GCF. So in here, the GCF is -1. And then we have x. So -1 can be applied to anything because anything at least has a positive number is just -1 times -1. And then times that number. That's +5. So by saying the GCF is -1, meaning I can just take the negative number out of here and then make that negative, and that totally works. And now we're going to take out an x, meaning that we have an x at least in both terms here. That's how we have -x. And then we just put that GCF on the outside here, multiplying the entire thing. And if you did it right, -x times this whole thing should get you back to where you started. So negative x times 3x gives us -3x squared, and -x times 5, -5, gives us +5x. So you know you did it right if you can you did it right if you can go back to the original step. Okay. Now in the second number, or in the second pair, we have a GCF of 2, meaning both of these numbers divide by 2. What I would start with first is find out if this second number is divisible by 6. If it's not, then just figure out what both numbers divide by. But generally, the first number you want to try is the biggest number, or the first number you want to try is the number that's out front. And you know you did it right if you've got the same pair here and here. Now we've got -x and +2. Combine them into one term. Now you have -x plus 2 times 3x minus 5. Simple. Right, clear the drawings here. All right, so to multiply two factors and expand the polynomial, we multiply each of the numbers in the first term by all the numbers in the second term, aka we FOIL it, meaning that's first, then first times the outside, then inside, then last. And you add them. You add all of the terms together. So the first one, that's x times x, that's x squared. The outside is x times 1, it's just x. Inside is 9 times x, and the last is just 9 times 1. So you add them all up, x squared plus x plus 9x plus 9. Combine the two terms, x squared plus 10x plus 9. Any questions? If you do have any questions, just email us at mark@brightpoint. Yeah, again, any questions, just email us at this email, and we will be happy to answer them. Thank you. You have a good day.